In the beginning, a few words about ZAPTEST. As a company, we've been in the business over 20 years. We position ourselves as a full-stack cross-platform testing solution. With ZAPTEST, you can automate applications on mobile, Windows, Mac, Linux platforms, and we fully support agile development methodology. We are based in Atlanta, Georgia. Our core technology is one script, which allows us to script test procedure once and execute it anywhere. We are the test optimization leaders, which means that with ZAPTEST you can automate any application, you can meet any development schedule, and you can accommodate any skill set of your team members. As a full-stack technology, we provide end users with test automation in a cross-platform fashion. This means that you can create your test script in one platform or environment and play it as is anywhere else. Besides that, we offer other technologies which are not commonly offered in the industry. For example, with ZAPTEST, you can auto-generate test documentation. This may offset a lot of man-hours of writing documentation manually. ZAPTEST can do it for you. We also have technology for parallel device execution. The MRAM ensures just-in-time regression testing. With MRAM, you can connect to multiple devices with different platforms or different browsers and execute same tests simultaneously on all of them. We also have device host management private cloud system, which we provide to ZAPTEST users. The farm offers test device management capability and provides universal access to the devices across organization for the purpose of mobile application deployment, manual or automated testing, and for parallel test execution. With ZAPTEST today, you can do API or web services testing. You can use the tool for an API standalone test automation or for building combined API and UI testing framework. Recently, we released the load component, which enables our users to do API performance testing as a continuation of quality assurance process. As you can see today, ZAPTEST can be used as a one-stop solution for majority of quality assurance needs. Okay, let's move on to main part of our webinar. At the end of the webinar, I will allocate a few minutes for a Q&A session. So today we will be talking about object types in ZAPTEST. I'm going to start with application object. Application object allows us to access application under test. ZAPTEST adds application object automatically. We cannot define application object manually. And this can be done during the scanning. In my example, I will be scanning the browser window. During the scanning process on the Create New Application Object window, you can update name for the future application object. I can use any name for the object. Once the scanning is complete, ZAPTEST will add all objects to the repository explorer. And on the top level, you will always see your application object. When you navigate to the application object, you can explore related properties. Two properties from this list are used to identify your application under test. And these are class and title. Values in these properties are used by ZAPTEST to uniquely identify your application under test window. Besides that, ZAPTEST uses detection type. If I expand this drop-down, you see different detection types. Default one is flexible. Flexible means that ZAPTEST may potentially auto-adjust values in order to locate your application under test. In some examples, some situations, you may need to run your test against different browsers. And flexible detection types allow ZAPTEST to identify different browser windows for the same test. With this detection type, ZAPTEST will first attempt to find your application using exact matches for class and title. If it cannot find it, it will slightly modify title property. It will remove reference to the browser. In my case, it's Firefox. Also, it can remove value from the class. Eventually, it will locate your application under test. If application is not found after all these internal procedures, ZAPTEST reports application not found error in the test results. As you see, ZAPTEST may potentially perform many internal things in order to identify application under test, which potentially may slow down the execution process. Alternative way is to manually set detection type to exact match. With exact match, ZAPTEST will look for exact values for class and title in your application under test. Although you still can use partial values with the exact match for class and title. In my example, if I remove reference to the browser from my title, ZAPTEST will be able to locate it. Also, I can remove reference to the Firefox in my class, and that will also enable ZAPTEST to identify my browser using part of the title. So in this way, I can apply this application object to any browser, Chrome, Firefox, or IE. Important property in the application object is activate window. By default, after scanning, ZAPTEST will use true for activate window, which means that ZAPTEST will bring your application window in focus before interacting with objects on it. Some object types, application types, specifically pop-ups on a web or application windows, may require the activate window property to be set to false in order for ZAPTEST to successfully operate with object inside it. If, for example, you see that ZAPTEST identifies your application correctly, but unable to type values inside the text boxes, in this case, you may want to try to change activate window property for that window to false instead of true. Keep in mind that with this selection, ZAPTEST will not focus on the application under test automatically. So you may need to add steps to focus on it first. Okay, let's talk about some specific methods for application object. In my test script, I will add application object, which is ZAP. And here you can see that it has unique method called launch. We can use the launch method to open or launch application under test for ZAPTEST to work with it. First argument is required, and using the first argument we can specify what application we need to launch. If it's a browser, we can simply include browser type like Firefox, Chrome, or IE, or Edge. Second argument is optional and can be used to either provide URL for the browser to navigate or path for the document to open if it's a document file. So this particular step will launch a new instance of Firefox browser and navigate it to our website, zaptest.com. If I run this test, we can see that the browser window has been launched and navigated to the home page. Often we need to work with multiple applications within the same test. In this case, you need to scan your applications into different application objects. In my test example, I want to read part of the text from my website and copy it to the notepad. First, I will scan the notepad. And I need to make sure to create new application object for this. As you see, after this operation, I have two applications, one for ZAP, another for Notepad, one for browser, another for Notepad window. And of course, Notepad window will reference Notepad application window in its class title properties. In my test, I want to grab some text. I can use this object to get the text. I need to assign the output value to the variable, and then I can use Notepad application to type this value to the Notepad window. And as you see, ZAPTEST was able to type the value inside the Notepad window. So again, I use two different application objects to control two different applications, local applications in my test. With application object, you can use exist method. Exist method verifies that the application exists. You can use it inside if statement, of course. So this is a way to confirm that required application is visible on the desktop or on a test environment. So this was the application object. Next object that we will talk about is the view object. The view object, like application object, can be added by ZAPTEST during the scanning process. There is no way to add it manually. View object in ZAPTEST is used as the collection of other objects. During the scanning, ZAPTEST will always define application, view, and only inside the view all other standard objects. View by itself is not used for identification. There's not many properties for the view as you see. We can change a logical name for the view, and we can specify Zoe scan mode for the view, which can be passed to all other children objects. Although ZAPTEST keeps the view image, which can be used for verification purpose. How we work with the view? We enter the view object to the test script, and here you can see all the properties that the view object supports. If you need to verify the view, you can use exist method. With the exist method, ZAPTEST will verify entire view or entire image of the view and compare it with the view at runtime. So what that means is, let's say for my notepad, I have this application window with the view scanned, and if I want to use it to verify if correct view is present during the test run, I can have it with the exist method. In my test example, I will add two steps to verify the notepad view. One before I type the value and another one after I type the value. I'm going to run my test again. And I will open and explore test results. In my test results, you can see that the first verification that I used against application reports the object is found. Then I used exist with the view for Notepad. It tells me that the view is different. Also, it provides the screenshot with the highlighted differences. On this step, I see that the difference in the title, if I look at the view object for my notepad, it doesn't have asterisk. In the results, I have the asterisk, so the ZAPTEST highlights area that has been identified as a different. After I type the text in the notepad, there are another different area added for the view verification. So this is how exist method works with the view object. In my steps, I use timeout 5 seconds. This is because when the view is different, ZAPTEST will wait until timeout for the correct view. I don't want to wait for too long, so this is why I limited the timeout by 5 seconds. Okay, next object which we will talk about is the area object. Area object has to be defined manually. ZAPTEST will never add area object during the scanning process. To demonstrate the area object, I will open a new test and I will use this file. So this is text file with some information. For my test, I want to identify a state of Georgia from this table, and I want to interact with this. So let's say for my test, I can simply double click on the Georgia's population number. As you probably know, you can use relative object as one of the approach to access the values. Since we have Georgia defined here, we can scan it, we can use Georgia as a parent object, we can define population number as a relative object, and we can access it. Let me scan my notepad. So the approach that I just described would be to have these two objects and make this object relative to the to its title. In my case, it's Georgia. But keep in mind that to recognize the Georgia object, ZAPTEST needs to have to set its appearance. Since I have two Georgias, one on the top part, another on the bottom part. If these tables switch positions, then my test will fail. ZAPTEST will find Georgia, which belongs to this Georgia. So we'll not be able to capture value of the population anymore. A good alternative to this method is using the area object. How we define area object? I want to keep this object. And I will keep this object, and this is it. Let me remove all others. Okay. To define the area object, I need to add object manually. So I press the Create button. I need to specify a name for the object. And for its type, I need to select area. As a next step, I need to go to the edit mode for the area and move it to the position where the area should be. I want my area to include only second set of states. Also, I need to define the area as a relative object. For this, I'm going to select its parent. Now, in order for ZAPTEST to find object inside the area, I need to make it relative to the area. So for this, I need to use the Georgia object and select relative object for it, which will be the area. You can notice how construct changes in the repository explorer. I have state and population, which is parent object to the area. Georgia, which is child object to the area, and relative object with the population, which is relative to Georgia. For the Georgia itself, I need to remove reference to the appearance because I have only one Georgia inside the area. If I keep number 2 for appearance, ZAPTEST will try to find the second one. So I need to change it to the best match. Right, I can verify if ZAPTEST is able to locate my Georgia in the correct place. And for this, I use the locate tool. Let me add step to perform the double click. First, I will verify that my parent object exists. And then I can use double click against the population object. In your test script, you will see the same construct. Application view, parent object area, object inside the area, and any other object which is relative to this object. Okay, let me run my test. Okay, test works. Now you understand that if these two tables switch positions, ZAPTEST will be able to find Georgia and its population without any problems, since we have title of the table moved together with the table itself. Okay, what happens if my application comes with changed outline? And now it looks like this. Since I'm using relative object for the Georgia's population, ZAPTEST will try to find it empty space. So in this situation, when the position of the object, population object may change, we may apply another area. Let me add another object. I will define it as an area. I will move it to cover any potential spot where the number for the population may appear. I can make it up to the side of the application window. Now this area has to be made relative to my Georgia object. The population object itself needs to be made relative to the area. Okay, let me verify the construct. I have view statement population, area, Georgia, another area, and under that I have the population object. Okay, let me run this test and verify that ZAPTEST correctly identifies the position for the population object. And it works. Now a little note, when we have this construct, I'm no longer using a relative object for the population. So ZAPTEST identifies by its text. What happened when the text of the object has changed? Let's say I don't have 10.5 million for Georgia, but something like 22.1. There is a potential that ZAPTEST will not find this object because its text has changed. What we can do in my precision level for the population object, I can change it from medium to low. This means that ZAPTEST will tolerate differences in the text value and find this object pretty much with very different number of millions for population. Let me run this test, and you see that identifies the object correctly. So this is how we can use area, a combination of areas to accommodate changed interface for application under test and correctly locate required object. Another type of object that we have in the object list is so-called standard objects. When we get the application scan, ZAPTEST will add those objects. We can define those objects manually. Those objects include OCR type objects, image objects, or coordinate objects. I will not cover those objects during this webinar since I talked about those objects on previous webinar. I will just show you. So when we have the scan performed, ZAPTEST identifies those objects by their types automatically. OCR type object, image type object. Also, where you may have relative object automatically defined if you have auto anchoring enabled. If you want to use coordinates type object, you can use any existing object and switch its recognition type from OCR or image to coordinates. Also, you can define any of these type objects. Okay, we'll move on, and the next object that I want to talk today is list object. List object has to be defined manually. let me open. Yeah, I can use this application as an example. So list object allows us to access and control a list of values organized vertically. It can be used with any list-like view values. It can be used against drop-downs. It can be used against list boxes. How we define list object? On this example, let me keep this object, remove all others. I have clear view of this application scan, and I will add one object, name, and for the list object I need to change its type. So from the type list I select list type. For list I need to specify number of rows. Those rows correspond to number of rows that are visible for that object. I want to define a list which will include all state capitals. In my case, I have 4 rows, so I specify number 4. And as a next step, I need to go to the edit mode for this object, for my list object, and drag it, resize, and position it around my list of capitals. This has to be done accurately. The list object, in turn, has to be set as a relative object. So use state capital as its parent. Object repository includes my list object with specific icon. You can see it here. And it clearly seen that it's relative to its parent. What we can do with list object? Let me add some steps. Once I drag or drop the list object, I can see some specific methods. Of those, we can use click row or double click row. We can use find row. We can use get row text. We can use get row y, get row x for coordinates and pixels. So let's review some of these methods. I will use double click row, which basically works the same as the click row. In my example, it's better since I'm working with the notepad. When we use click or double click row, we can specify 2 types of the first argument. It can be index of the row or text of the row. And ZAPTEST uses the same method for either one. If I need to click on a specific row by its index, I can simply include the numerical row index like this. If I need to click on a row found by text, I need to include value of the row. So in this step, let's say I want to click on a row. So I typed its value. All right, let's run this test. So you saw that the first test clicks on the row with index 1, which has value Tallahassee, and then it clicks on the row with value rally. If I need to use to find row with a specific value, I use find row for this. And I need to specify a value of the row which I need to find. So in this example, I will use Atlanta. This method returns value, so I need to capture it using either the variable, or I can simply use message box for my demonstration. So the output of this step is number 2, which is the row number for Atlanta in my list. Also, we can find which row specific value present. For this, we'll use get row text. This method also returns value. So use message box. So during the test run, I expect this step to return value from the row number 3, which is Montgomery. Let's run this test. And it correctly identifies and returns value from the row number 3, which is Montgomery. Sometimes we need to find a position of a specific row. For this, we use get row y or get row x. Correspondingly, we'll get x or y position of a specific row. With this method, I need to use index of the row. So when I run this, I can clearly see a difference in the y position for row number 1 and row number 2. The value is in pixels, of course. Similarly, I can use get row x. When I run this test, I should get similar value for the x, since both x, first and second row, have the same horizontal position. All right, so this was list object. Let's move on. Next object that I want to review is table object. For table object, let me get another file. Like list object, we need to define table object manually. Steps are the same. Let me scan this application, which has table that includes state, capital, and population. I will keep this single object parent, delete all others, and I will define the table. For this new object, I need to select its type, table, And of course, I need to define rows and columns. For columns, I have 3 columns in my table, and for rows, for the number of states. Next, I will go to the edit mode and position my table to precisely cover table on the application under test. And I need to make it relative. So I use state as the parent object for my table. For the table, we can use some specific methods. Let me define a few of them. First, I include a step to verify a parent object. Then when I drop the table, I can use methods like click cell, double click cell, get cell text, get cell column, get cell row number, and few others. So let me make some examples. For click cell or double click cell, I will use double click cell since I'm in a notepad. Similarly to list box, we can list table, we can provide reference to the cell using its row or column and just text. So in the first example, I will use row and column reference. If I need to click on a cell with specific text, I need to include its text. Okay, when I run this test, I expect it to first double on the cell with Atlanta, which is has position 2 and 2, and then on Alabama. Let's run this test, and it works correctly. If we need to retrieve text from a particular cell, we use get cell text method. Here we need to specify position by row and column. This method returns. I will use message box to display it. And it returns population of Alabama, 4.9 million. Its position is third column and third row. Sometimes we need to retrieve a specific number of column and row for the table where we have certain values. For this, we use get cell column or get cell row. Include some couple examples. Okay, this is population of Florida, so the column number should be number 3 to the message box. Let me add one more. If I need to get cell row, like in the previous step, I need to provide the value of the cell. Okay, so it correctly identifies number of the column where I have population Florida. It's number 3. And for Atlanta, I get row number 2, which is correct. Okay, so you can use table object in this format when you have your table values properly formatted. In my case, I have widths of columns equal, and therefore my table object works perfectly fine. If we have table object with uneven column widths, let me modify my table here. We'll scan it and replace existing view. If I try to use the table object which I have defined, I may have problem because column width is no longer the same. So this object is no longer applicable for this type of table in the application under test. In this case, we need to switch to dynamic table. In my table object properties, I have dynamic table value, which is by default false. When I change it to true, I switch to dynamic table. With this setup, ZAPTEST will automatically define number of columns, number of rows. All I need to do is to specify where the table ends on the bottom and on the right side. And for this, you can use any standard ZAPTEST object. I don't have objects here either on bottom or right part, so I can define those objects manually. So this object will define bottom part of the table. I can make it relative. And this object will define right edge of my table. I will also make it relative to the state object. Now in the table, I need to include this object for bottom and right definition. As you see, the process is very simple. Once you have objects in place, just click the corresponding button for right and bottom. And this is it. Now my table object is dynamic. I don't need to modify anything in the test script itself. And when I run it, test correctly identifies or performs all the steps and retrieves all the values. Sometimes we have type of table that is not fully visible. With dynamic table, you can let ZAPTEST to automatically recognize when the bottom of the table. For this, I just need to unselect my bottom object and select dynamic and detection to true. This means that ZAPTEST will perform a scan of the table, number of scans, until it detects that scroll and scan no longer works. So this helps ZAPTEST to identify bottom of the object dynamically. If I run my test, I expect to get same results. So ZAPTEST correctly identifies bottom of the object without including the bottom object reference through the dynamic object detection. Okay, the last object that we left to cover today is a swiper object. Swiper object is used to perform swipe operations specifically against mobile devices. To demonstrate this object, I will connect to my mobile device. I use ZAP viewer. This is the Android phone which I have connected directly to my computer. From the list of applications, I will use Chrome. Once connected, I can view interface of my phone through ZAP viewer. I will use this as application under test, so I'm going to scan it. Let me keep ZAPTEST object. And I will add new object for swiper. For its object type, I select swiper. Swiper appears as a starting and end point on the GUI. Once in the edit mode, I can set swipe start and swipe end position. Like this. And to use this object, I can simply include it in my test script. For this object, we provide swipe up, swipe down, and swipe percent methods. Let me use swipe up, and then I will use swipe down. Just remember then, swipe up performs swipe operation opposite to the direction of the error in swipe object definition, and swipe down performs swipe operation in direction of the error. So when I run this test, let me change application, activate window to so you can see the viewer. And see it performs two swipe gestures. One goes up and another goes down. Beside that, we can use swipe with a certain percentage definition. In this example, I can perform swipe half of the distance of my swipe object. For this, I need to start with 50% and with 0%. So it will perform swipe up. So let me run this test and see all three swipe actions, swipe operations in place. So this is where my last swipe ends. Just a half of the distance of my swiper object. All right, so we covered all the object types that ZAPTEST provides. I will stop my presentation for now, and if you have any questions, please let's move on to Q&A session. Again, we have a few more minutes for the meeting, and submit your questions using the private chat. Okay, first question I see, is the presenter going to go into ZAPTEST recorder feature or option? No, we're not going to cover this during this session. We will have a specific webinar for this. Okay, next question I have, you are using message box to display output values, how to send them to results instead? It's a good question. We provide optional method report for this. If you set to true, you will get all outputted test results automatically posted in the result. Another question I have, what restore window size property does? Good question. Restore window property, I think I mentioned about this. Its name is restore window size on startup. What it does, when selected this flag to true, it will launch your application under test and set its width and height according to the provided values. So there may be a situation when you need to launch it with different window size. In this case, you can update these values or use parameters and make sure to keep restore window size flag to true instead of false. This is how you will achieve required size of the application under test after launch. Beside that, the application you can use, let me show you this example real quick. Drop the application object. If you scroll down, you will see set window location, set window size, and set window state. So these methods allow you to set application size and position during the tested runtime or change it. All values provided here are in pixels. And for Windows state, you can specify either normal, maximized, or minimized by providing the number like it appears in the tooltip. All right, we're at the top of the hour. I need to conclude my webinar. Thank you very much for participating. Keep using ZAPTEST. If you have any questions or issues, use our forum, submit our posts, and we will be glad to answer you. Thank you very much. See you on our next webinars. Goodbye.